Hi everyone, this is Vikas from Networkers Home, and today we are going to cover two topics, which is TLOC and TLOC Extension. Further, I'm going to have 8 subtopics inside it, and we are also going to cover 6 labs, which probably will be in the next video. So here in this video, we are discussing TLOC, TLOC colors, TLOC groups, TLOC restrict option, TLOC carrier option, TLOC extension theory, and TLOC extension 2 and TLOC extension 3. So let's get started. So what is TLOC? Now TLOC is by definition is a transport locator in the transport VPN 0 VRF, you can call it, or if you want to call it transport VPN. It is one of the interface that has couple of information attached to it, so that when it goes to the other site is able to make out, is this connection coming from the internet, or is it coming from MPLS, or is it coming from IPsec, or is it coming from GRE, etc. So the couple of values are basically attached to it. Now as you can see here, so what are the values attached to a TLOC? A TLOC is uniquely identified by a tuple of 3 values: system IP address, color, encapsulation. Right. So system IP, as you are aware of, is a very unique router ID kind of information, which is attached to each VH into our SD-WAN solution, and that basically represents the unique router ID in the network. Right. It acts like a router ID, you can call it. Even if it is not routable, you can give any IP, that's absolutely fine. Transport color, there are around 22 colors by default in Cisco, and these are basically defined as the public colors and private colors. And the purpose of this is that you can do a lot of advanced features based on the colors as well. Then encapsulation type, right? We need to know if the connection is using IPsec or GRE, etc. So here I have this scenario. Now we have to find out what is transport locator here, right? So it will not be wrong to say that this is one transport locator, right? This interface is basically going to get converted into TLOC, right? Because it is running OMP by default on the transport side as well as all the service VPNs. So OMP is going to attach whatever information that you are adding to it, and that carry that information to vSmart, and that information when sent to vSmart, right, he can make out that are you using MPLS, or are you using internet here, etc., etc. Let's say you are using MPLS, there is another connection called GE01, and here you are using MPLS. So in that case, your vSmart will know that this guy has 2 TLOCs to reach to this particular VEdge, and this is MPLS and this is internet connection. Also, it will find out what kind of other information you have, like are you using GRE or are you using IPsec, etc. So okay, let's go to the next slide here. So we can see that it's a couple of information attached here. You can see the TLOC is basically the color is given as green, and it's almost the same slide. So what is the default behavior? The default behavior is WAN edge routers try to form an overlay tunnel to every TLOC over each available WAN transport, including TLOCs that belong to other colors if there is an IP reachability between the two transport network. What does it say? That it basically says that you will try to form a tunnel to each device. Let me pick up a pen here. If you have a couple of sites, so by default the behavior is that you are going to form a tunnel to all the devices. By default all devices are going to form tunnel to each other, right? So that is the default behavior. It's going to be a full mesh, whatever links you have. So this guy, let's say he has link number 1 and 2, he is going to form tunnel over this link, and he is going to form a tunnel over this link, right? If they have 2, then that's again going to be the full mesh will be two links each. So right now this guy is going to have two TLOC neighbors, 1 and 2, right? Plus then from this interface is going to have 1 and 2. So total 4 TLOCs will be basically available because he has, right, two interfaces. But these guys are going to have two TLOCs. They will form a full mesh from this link to this link. And if this is basically a private connectivity kind of thing, so the better idea would be to have something like this. He has one link, this guy has two links. So we are going to see this in detail in next couple of slides. Now the next thing, there is an exception here which says that if you have two sites in this under the same site ID, right, two sites under the same site ID, they will not form tunnels to each other, right? So you need to be in separate site IDs. You are site 10 and this is site 20. In that case you can form tunnel to each other, that is absolutely fine, but you cannot form a tunnel if you are part of the same site. If you're part of the same site, that will not work out. So that's a default behavior in fact. So as we can see here that we have multiple interfaces here, and this is VH1. It has two transports, T1 and T2. So how many TLOCs are going to be there, right? So we'll see how many TLOCs are there. So TLOCs essentially is one TLOC, second TLOC. But how many neighborship is he going to form? By default the rule is full mesh. So he is going to form one, and then depending on how many connections this guy has. So basically how many, this is a single site, right? So each is going to form one interface is going, this is one TLOC is going to form two neighborships, right? Similarly this is going to form two neighborships. So total on VH1 you will have 4 neighborship, right? So 4 neighborships are going to be formed, or you can, if you want to call it IPsec or GRE tunnels, basically. So 4 overlays are going to be created over this. So that is a default behavior. But as you know, we discussed that if you have another device here which is also part of VH site 20, right, in this case, which is part of site 20, so this, it will not form any kind of TLOC tunnel with this device. That's a normal behavior. Okay, so what is TLOC color? TLOC color is basically just a logical naming convention to identify a WAN interface from another interface, as we discussed last time, right? That if you have a device, you can basically have let's say this is one VH has 2 links, so we require some kind of identification which later can be used for multiple purposes, okay, which you are going to see that very soon, that if this is particular VH1, let's call it, and he has 2 interfaces, gigabit 00 and gigabit 01. So we need to have some kind of identification, right? So this becomes MPLS, or this becomes biz internet, or any other naming convention. So 22 are default, plus you can create your own naming convention also, right? So public and private default naming conventions are basically there. So this is just a distinguishing mechanism. You distinguish between these 2 interfaces, nothing more than that. So here you can see that we have VH1, VH2 connected over 3 transport, right? So we need some kind of identification of how this particular communication should happen. There are 2 ways. By default is a full mesh, but using a lot of customized policies and a lot of centralized policies, etc., you can actually customize whatever way you want to customize. But by default is going to be a full mesh among all interfaces except its own site. So how do you configure it? You just go to your transport VPN, VPN 0 interface, and then you can give color under the interface IP. There are 22 predefined color keywords, and these are basically categorized into two categories: public and private colors. What is the significance of public colors? Generally, the purpose of that is that these are going to be connecting to internet, or like LTE or whatever type of internet connectivity you have. It could be lease line, it could be DSL. Okay, so in that case, what will happen? We can differentiate between a private network and a public network. Now, when you say private network, generally what happens is we do not use netting, right, when you are using MPLS kind of thing, because it's a private to private communication. So that is where the differentiation comes, but there is no hard and set rule as such, except that you can tweak a couple of things which we'll see in the next couple of slides there. So these are the default colors. All 22 colors are by default here. You see public colors and private colors. Also, you can create your own custom color. You can give it any naming convention that you are comfortable with. That's absolutely fine. So how does the communication happens between the colors? Okay. So during the authentication process with vBond orchestrator, WAN edge devices learn whether they sit behind a NAT device, and that is their netted address or port. This is done using Cisco netting or STUN protocol, which is used by Cisco. In fact, I think it's an open standard protocol used by Cisco for netting. So let's say you have a public IP to public IP. So how is the tunnel is going to be formed? Will be basically, if you have the biz internet here and biz internet, which is public, right? So the tunnel should be basically formed over public IP to public IP. Although, you know what, there is a very interesting thing that there is a netting also happening, right? So you can see that netting is also happening, but the first try will be basically given from public IP to public IP. What if it is a public color and private color? Even if one of the color is public, the WAN edge device will also attempt to form the data tunnel using the public IP. Right? It will still try to use the public IP because of the color. This is a default behavior, right? And as I said, you are going to see all this in a different way when we start using the advanced features. You will see why these colors are like that and why this tunnel formation is like that. Communication between different color. What if it is a private to private color? If NAT, guys, even if you are running a NAT, what will happen? You are still going to have a tunnel between private IP to private IP. So that is because of the color that you are selecting. What is going to be the practical implication of this? Only when we do customized stuff, they will come to know about it. So what is a TLOC carrier? You are also going to see a feature called TLOC Carrier, right? So TLOC Carrier is basically, there are certain scenarios where you are using public IP address between private color, as it is, an example would be having two MPLS cloud that are interconnected using NAT. For such cases, there is a particular TLOC attribute carrier that changes this behavior. If the carrier setting is same in the local and remote TLOC, the WAN edge device attempt to form a tunnel using private IP address. If the carrier setting is different, then the WAN edge will try to form using public IP, right? So let's see what it is. Now you see that what is basically happening is that I have selected here on this particular interface as carrier 1 and here as carrier 2. Okay, so by default the behavior is that if you want to form a tunnel over public IP, right, even if it is using a private color, right, even if it is using a private color, you want to form a tunnel over public IP, you can use the same carrier, right? So if you have MPLS here and you have biz internet here, but they are part of carrier 1, right, their tunnel is going to be negotiated between both of them because of sharing the same carrier, right? So it will be built using the public IP, and if they are both using private colors, in that case it is going to be using the what is a TLOC color restrict, right? So by default what happens is, as we discussed, that you will have a full mesh, right? Let me draw it here, what we discussed. So by default what happens is you will have a full mesh. Let's say these are all connected over internet. So by default they will form IPsec tunnel, right, as a Cisco's default behavior to each other. So that means they are going to form TLOC peer or neighborship to each other, right? We don't want that. What we want is, let's say this guy is using internet, and he also has an interface called MPLS. So I want him, and this is internet, and this is MPLS. So if you use restrict option here, it will look for neighborship, it will look the same color. MPLS is going to form tunnel to MPLS, and internet will form tunnel to internet. Otherwise, if that is not the case, and you have this, if you don't use restrict option, what will happen? Internet is going to form TLOC with internet as well as MPLS also. Similarly, right, we pick up a different color. MPLS is going to form a tunnel to internet also, and this MPLS also. But if you choose a restrict option, you will be restricted to your own color. So very useful feature. Right, so you can see here that the tunnels are basically right now forming as full mesh, right? But if you apply the restrict option, you can see here that it's going to be IPsec to IPsec, right? This is full mesh, so it will form like that. But if you apply restrict option, it should not form the tunnel to the other interface. So in that case, the number of TLOCs will be reduced heavily, right? And that is a behavior also, because MPLS generally doesn't have a public IP. So what is the use of not having a public IP and constantly trying to form a neighborship to other resources, right? Through a private IP, you should not try to form a tunnel to the public IP unnecessarily. So how do you configure that? You just have to go to interface and give this color MPLS restrict on the transport interfaces, and as soon as you give the restrict option, you will have neighborship only to the certain color in individual devices. Now you see that once the restrict option is applied, you have T1 as the green color, and that is internet, and the orange is basically MPLS cloud. Okay, the next feature that we have is color group, right? So another option to achieve same goal of restricting data plane connectivity between same color is by using tunnel groups. Only tunnels with matching tunnel group will be able to form a data plane connection regardless of the color. So this is a very interesting option. What you can do here is, or what are they trying to say here is that, let's say if I have this particular device at one side, this is my internet connectivity, and these are different devices, right? And I have a couple of more devices probably. Now some of the devices here are using internet, right? Internet, this is probably MPLS, and this is maybe LTE, or this is biz internet. So what happens with the group here, group feature, is that if you put them into the same group, these interfaces, right, what will happen is they will forget about the other things like that I should form neighborship to this or that, etc. So they will form neighborship only to their group. They will not form neighborship. So let me give you an example. I will put a group value of 110, and this is also 110. So the TLOC membership, once a group is applied, this guy will not form a TLOC with anybody else. He is going to form a TLOC with this. How beautiful feature it is, right? How easy it does it make the Cisco SD-WAN VPN to have a site-to-site VPN between two or more sites, right? Control plane kind of management control done here with just one command. So if you want just certain sites to talk to each other, doesn't matter what color they are using, right? So this feature is going to override any kind of coloring that you do. Okay, provided you have not given restrict option. Do not give restrict option because that will override this. So if you have not given restrict option, this will take over the thing. It doesn't care about the color thing, right? It will only form neighborship to the certain group members. So TLOC Color and tunnel groups. By default in Cisco SD-WAN, vEdge will try to build a full mesh overlay by establishing IPsec tunnel to all other TLOCs regardless of their colors. Right? That's a default behavior. So right now we are in this slide we are comparing TLOC colors to TLOC tunnel groups, right? So what happens is the TLOC color will restrict us to somebody of our own color, right? That two people of the same color want to talk to each other, etc., etc. Although that will happen only with the restrict option. But with group, what will happen is that you will be able to group to multiple interfaces with multiple TLOCs with multiple color taggings. So that will be possible with the tunnel group. So this is one of the example here. I'm using tunnel group 1 here. Tunnel group 1, you see that on 3 sides I have one side MPLS, 2 side MPLS, one side Metro Ethernet, but I want them to talk to each other. In that case, what I'll do, I will put them into the same color. Now the interesting thing is these neighbors further will not be able to form tunnel to anybody else except their own tunnel group. So if you want to bring somebody else to their group, right, you can add them, and but if you want to form a tunnel to somebody else outside, you need either a separate interface which doesn't have a tunnel group, right, because this interface is right now participating into tunnel group. So in that case, the only option left to you is you create one more interface and do not give it any tunnel group so that that can form neighborship to other devices in your network. How do you group different color? Of course, we have just discussed that you can use different tunnel groups, and then there is no need for coloring, right, to be matching. You can basically have different colors as part of the grouping. Also, tunnel group could be utilized to create topologies. How interesting it is, right? This is what I was talking about in the previous scenario, that if you have multiple interfaces, you can put couple of interfaces into couple of tunnels, right? And I'll go back to this. So if you look at here, right, these tunnel, he has a different topology. You want to call it hub and spoke or whatever way you want to basically configure it, you can configure it, right? Otherwise this is going to be a mini full mesh, this is going to be their own full mesh kind of thing. Now you see that by doing this, how many connections you are avoiding, how much traffic, rerouting or routing loops and other things you are avoiding, etc. And unnecessary traffic also you are avoiding. So you are basically creating two different topologies using this particular method. The last feature that we have is called last resort circuit. Here, what is last resort circuit? This is a circuit on your V edge which is only going to be used when you are the main, whatever connections you have are already down, all of your connections are down, and you want to use this particular circuit as the gateway of last resort kind of thing. What is the meaning of that? Let's say you have a lease line, you have this is a V edge which has two connectivities, you have LTE or 4G here, and you have lease line kind of thing. You do not want to use 4G because that is expensive, so you want to keep it as a backup, and this lease line is unlimited data, right, for certain amount, so you want to use it as all the time your communication network should be on this particular lease line. What if this goes down? Right, so easiest method is to configure this as last resort circuit. Right, let's say if you have MPLS also, so depending on your policy from internet it will go to MPLS, and if MPLS is also down, then only this circuit is going to be used. So you look at it, very complex features with very simple commands, you can actually achieve a lot of stuff with these features. Right, so next feature that we have is TLOC extension, and this is a feature which is practically used in almost all companies because it saves a lot of bandwidth, and most of the companies have some kind of redundancy here on their V edges, right, from design perspective, because if one of the V edge goes down, the second V edge should be always up, etc. Right, so that's the reason the design is like this. So what TLOC extension does is that, let's say you have one internet connection, one MPLS connection here. So this is a certain site, let's call it site ID 10. Okay, so this internet connection basically, right, all the traffic you want is to go through this particular internet connection, and all the MPLS traffic should go through the MPLS connection. Okay, what if tomorrow, right, because of ABC reason your MPLS thing goes down, right? You had certain user here, they were passing through MPLS, now MPLS is down. How will you actually go to this particular connection? From here there are a couple of methods, like you can use VRRP if they are on the same subnet, etc. right, and you can have VRRP for the same subnet, and you can basically switch over between these two, etc. Or what you can do is you can create a TLOC extension. So in TLOC extension, what happens is that these users do not need to go to the internet through this. He can also have an internet connectivity at this interface. Similarly, this interface physically, this V edge physically doesn't have MPLS link, but we can do TLOC extension so that this MPLS circuit can come here. Okay, so what happens is if we talk about from configuration perspective, this is the internet connection, let's call it gigabit 00 GE00, right, and this is, let's say, call it GE02, right, this is also GE02. So you want this interface to be the extension or TLOC extension for this particular interface. Okay, which means that this interface will facilitate this particular interface here, right, will become a TLOC itself, and it will pass through this, and it will pass through the VPN, this particular interface itself, but it will become a virtual extended network passing through this particular interface going to the internet. That means there are two TLOCs on the one physical interface kind of thing here. Okay, so two TLOCs through VPN 0 is what we are talking about, because GE00 is essentially, right, it doesn't have internet connectivity, it is just extending itself, right? Although the real extension happens here, this is just a facilitator. So what are you extending? Are you extending this to the internet, or are you extending this to the other side? This is very important to know. So practically what are you doing is you are extending this interface through this interface, taking it all the way to here. Okay, so you are taking this internet connection, it will be like this, right? Although virtually it is passing through this, but it will be like this actually, right? Although the real communication is going to be like this. So that is what is TLOC extension. And so there are two type of TLOC extension. We have L2 TLOC extension and L3 TLOC extensions. Most of the time in the practical world, we use 98% of the time we will be using L2 TLOC extensions. So what happens in L2 TLOC extension is that you need to have a layer 2 device or physical connectivity of these devices to each other, right? So they should be on the same L2 segment, which means there should not be a layer 3 device between them. They should be able to communicate to each other, like you have seen on Cisco ASA firewalls, right? The failover interfaces connected to each other. This is your L2. And when we are going to do the lab today, we are going to do L2 itself. Now let's look at L3 extension, right? So this is L2 itself. L2 extension describe extension between VH that are L2 situated in the same broadcast domain or the same subnet. Also we also have an option for L3 TLOCs, but that is going to require that you have L3 device. It could be one hop away or different, can be far away, but in that case you have to use GRE here on this particular interfaces, right? Not even recommended in Cisco documentation heavily. So what are the limitations of TLOC extensions? TLOC extension can be configured using any physical interfaces or L3 subinterfaces, but it cannot be configured using the SVIs or the switch ports, etc. Right? You know that, right? SVIs can be used. You can create SVIs, map them to interfaces, etc. Right? So that is not allowed for TLOC extension, but for simple service VPNs you can do that. LT cannot be used as TLOC extension interface between VH routers. L3 TLOC extension is not supported on Viptela VH routers, but only supported on Cisco CSR series or other devices running Cisco iOS XE. The feature would not work on transport port that are bound to the loopback tunnel. So you need to have some kind of physical interfaces on your transport links. Make sure you do not have loopback, because the feature will not work with loopback interfaces. What are the routing consideration that we have? So a TLOC extension interface is always configured in VPN 0, right? Because you are extending your transport to the other side and has an IP address assigned. Then the WAN interface to which it is bound is specified. So here we can see that there is a internet connection and there is a MPLS connection, right? So two TLOCs are basically happening. See that two TLOCs are happening. Let me pick up the marker here. So let's see which one is which. So this is TLOC extension for internet, right? We can see that this is extended and this will become a public TLOC for this particular. So there are two TLOCs, GE1, this is extended here, extension, right? and this is the physical interface. Also, this side users want to go to MPLS, right, through this, and internet through this. So what they are doing is they are configuring the second TLOC. So two TLOCs are configured. One is basically this side of network utilizing internet this way, right? The other thing is this side of network utilizing internet or the MPLS connection through this way. So couple of design consideration. One thing is generally, let's say you have a public IP or etc., whatever it is, right? So so you have to point your default gateway toward this interface, static route toward this interface, okay, for the internet connectivity. Also, this interface should be NATing your private IPs, because this IP is not advertised to anybody, right? There is no NATing happen. You have to NAT it to this particular interface here, right? It could be PAT also. If you are doing general PAT, that is absolutely fine. It supports PAT. So you have to make sure you enable NAT on this interface so that this IP can go to the outside world using this particular IP address itself. But in TLOC extension, when we do the command and we verify it, it will be actually mapped to public IP, right, which is going to be your public IP here, whatever was public IP, and a private IP. In TLOCs, generally what happens is, in general TLOC, what will happen? You will have public IP and private IP both same, right? So here it's basically going to change. So that is the consideration for internet. What happens to MPLS? MPLS also same thing. This subnet, the subnet that you have between this interface and this interface, let's say you have this subnet as 192.168.5.0/30. Okay, so this network, how do you advertise to your MPLS provider? That is going to be your challenge. Okay, you have to make sure that you are running some kind of routing protocol with your MPLS provider, or MPLS provider has a static route for you, because you can't do netting, right? Generally MPLS are pure MPLS private circuit. You don't have public IPs, etc., right? For they don't do netting, etc., because they don't provide internet. So depending on what kind of MPLS you have, MPLS or MPLS plus internet, the situation will decide what to do, right? So here in that case, this particular subnet has to be advertised, and for backup keep a default route pointing toward this guy, and here a default route on this particular device VH2, default route pointing toward this IP, here default route pointing. Even if you're not pointing a default route, that is absolutely fine, frankly speaking, because you have all the private routing table available to you, so that's absolutely fine. So that is the routing consideration of the TLOC extension. Now this is the configuration on the internet side, right? Very simple configuration. You see that NAT has to be enabled, right? On the VPN 0, on the interface gigabit 00, there you have to do NAT, and on interface GE4 you have to do TLOC extension, and you are extending which circuit? You are extending this circuit with this particular circuit here, right? So this circuit is being brought up here, which will actually extend up to here, and a default route on VH2, right, so that you can go to the internet, because this is going to be a default gateway for all devices. The internet traffic will be passing here. What are some of the verification command for TLOC extension? Very simple, two commands are there: show OMP TLOCs and show BFD session. So guys, this was a theory portion of all these features plus TLOC. Now in the next video I am going to cover the configuration of all these features, TLOC, TLOC extension, and all the sub features. Okay, at the end I would like to summarize what are the things that we have covered in this video. We have covered TLOC theory, we have covered TLOC colors, TLOC groups, TLOC restrict feature, TLOC carrier, TLOC extension theory, especially TLOC extension using L2. And in the next video, I'm going to cover the lab for most of the features. So I hope to see you in the next video. Thank you very much for watching. Take care.